You're finding a lot of what? Fairy tales, ponies, unicorns. What are you determining? Slopes of tangent lines. This entire section is just finding slopes of tangent lines. So you're going from a time equals 2, and if it lasts 0.5 seconds, what time period are you going to?
2.5.
To t equals 2.5, right? So it's t 2 comma something 2.5 comma something. How do you find the something?
Plug in
Yeah. 40 times 2 minus 16 times 2 squared goes right here, right? And what goes right there? 40 times 2.5 minus 16 times 2.5 squared. Does anybody have those points for me? When you plug in 2, what do you get? 16? Is that right? No? Yes?
No.
It's not right. So it's 80 minus 64, which is 16. Okay? So then this one's 100 minus something. What is it?
minus 32.
What is it? It's 0 right here? So you're finding the slope between those 2 points. That's all you're doing for this one, I. Finding the slope between those 2 points. So it's rise over run. So 0 minus 16 over what? 2.5 minus 2, which is going to be negative what? What's the unit on this thing? Feet per second, I think, right? I understand you guys are going to want to default to meter per second because that's what the physics world defaults to, and we managed to lose a satellite going to Mars because of that. Are you aware of that? $200 million satellite burned up in orbit going into Mars about 7-8 years ago. They couldn't figure out why, and then it became apparent one team. There was a calculation error based on meters instead of like feet or something like that. So like the angle of entry was wrong, and it blew up. It's like $250 million was gone because of a meter to feet conversion. Isn't that awesome? Yeah, rocket science. They can get something all the way to Mars. The landing is actually. Has anybody seen like the video of how the Curiosity landed? Did anybody watch that? I'm gonna pause this for 1 sec. Has anybody?
No.
You've never seen it? Here we go. So now what do? You do the same exact thing, but you're doing it for, what's 2 ask you to do it for? 0.1 seconds. So you're doing it from time equals 2 to time equals what? 2.1, right? So you're going from 2 comma something to 2.1 comma something. Does anybody have these 2 points for me? And I don't think you need to hug the bag. You can put the bag down.
16 and 14.5.
Yeah, it's 16 and what?
14.56.
Who got 14.56? Anybody else get 14.56? Everybody take out your calculator right now. Everybody take out your calculator. So you do this one. Someone do that for me. Can someone evaluate that and make sure 14.56 is correct? What'd you get? 13 point what? 45? 44 or 45? 44? Who agrees with 13.44? Yeah? Okay. So then you do the same exact thing. Can anybody tell me what the slope is going to be? What is it? Oh, come on. No one got it? Point what? 26, and it's feet per second, right? Great. So then you do the next one. Anybody have the answer just for the third one? Anybody have it? 24.8 feet per second. And what does the fourth one come out to be? Negative 34 point what? 24 point what? 0.16 feet per second. Okay, find the instantaneous. So this is the path. Remember how we looked for paths before? So we have this answer, and then this. It's theoretically, because the t value is getting closer and closer to 2, it should be getting closer and closer to the instantaneous velocity. Now, how do you go about doing that instantaneous velocity? What are you going to do? Limits. Remember, we set this up yet? We set up a basic limit, and it was the limit as t goes to 2, and what was it?
40t minus 16t squared.
16t. So that's, okay, yep, minus what? Minus what? 16. Why 16? When you plug in 2, right? When you plug in 2, that's what you get, right? Over what? There it is. So then how do you evaluate this limit?
You should factor out the 40t minus
Hold on, I'm going to pause this for 1 sec so we can discuss, right? Now things actually going to cancel. So now you have the limit as t goes to 2 of -8 times 2t minus 1 times t minus 2 all over what? Keep in mind that these statements are not going to be, once we cancel it, the statements are not identical, but the answer is. All we're doing is filling in a dot. We're filling in a removable discontinuity. This cancels, and you're left with the limit as t goes to 2 of -8 times 2t minus 1. What's that going to be equal to? -8 times 3 is -24. Now, does that match the path we took? Yeah, it looks like approaching what? Approaching -24. What does it mean for a particle if the velocity is negative in this case? The path, yes, it is slowing down because it's going from -32 to -26, -24. That's true. It is slowing down. But what does a negative velocity mean in this case?
It's either going left or down.
It's going left or, in this case, the particle, this implies that it's going down. This particle is going down. It was launched up into the air, the height. So this particle is falling, but it is slowing down. It is slowing down. Okay. So let's type in the actual function. Y equals, what was it? Sine of what? Sine of 10 pi, not e, 10 pi divided by x. And let's turn off. Have you seen how you can turn off a function? You turn off that equal sign. Have you seen that before? Let's graph this now and look what happens. Here's the actual function. What's this function doing? Still going crazy. What's one of the limitations of these calculators? What's one of the limitations?
It's not exact.
It's not exact because the resolution is poor. The resolution is poor. What's really interesting, this resolution is the exact same as the resolution of the TI-85 I used in high school. I'm pretty young, but that's a while ago, okay? I don't understand functionally why the resolution hasn't gotten better. I don't. So you look at where you anchor the point. Where's 1, 0? Let's trace this thing. If we trace, let's go to 1, 0 here. Where's 1, 0? There's 1, 0 right there. It's blinking. So let's clip this. So this right here is the actual function. Here is the actual function. Where's, oh, it's blinking right there. See this? That's 1, 0, right? So if you start approaching this thing and drawing secant lines, let's draw secant lines. So if we draw a first one here, we can anchor a point there. Here's 1 slope, right? Let's get a little closer. Hey, it's up here, right? So what might you think you could do to make these actually approach a limit? Get what? We could get closer, right? So let's take a look and see what this looks like. Let's zoom in around there. So let's do second, zoom, oh, sorry, the graph, what is it, zoom, box. Let's zoom in around 1, 0, right? So go a little bit to the left. Let's go all the way up to the top here. Let's go all the way to the right here. Enter. It smooths out a little bit. It looks like you can get closer. Does that make sense, everybody? So if we go back to this table value, let's do table set here. Let's not start at, what do we want to start at? Nate, let's start at, I don't know, 0.9. And what should the delta table be, meaning what should our step be?
0.
Let's make it 0.05, okay? You have to be careful because you might want to make it 0.01, but then how many times are we going to have to click down? A lot of times. So let's actually see what this looks like. Let's go to the table here. Oh, look, it's set on Y2. Why is it set on Y2? We've turned on Y2. We need to turn it on what? Y1, because that's the actual slope function. So there's Y1. Look what's going on. There's an error, right? Do we expect there to be an error? Yeah, because you can't plug in 1 into x minus 1 and not be 0, right? You can't divide by 0, but look at the values around it. What do you notice? What does it look like? It looks like it's actually approaching something, right? Let's get closer and see what happens. How do we change that? Start at what, 0.99? And what do we want delta table value? 0.001? It's going to be, look what happens here. Can we get closer? What should it be? Oh, there's an error. So what's the first thing you've learned now, remembered about your calculator? Well, it does exactly what you ask it to do, right? It does exactly what you ask it, nothing more. So what does it look like the actual slope is going to be? The slope is going to be between what and what?
Like
Negative 31.46 and what? Negative 31.38. So if you want to get more exact, what would you need to do? Essentially just go closer in, right? Make 0.001 and get closer. It's somewhere in between though. That's not bad. Think about that. We went in 10 times and it was suddenly not negative. It was saying negative 19.34 before, right? Okay, let's pause for 1 sec. If I said the limit as x approaches 7, how would you say that out loud? Can someone say that out loud for me? Yeah.
the limit of x squared minus 9 over x minus 7 as x approaches 7 equals q.
Equals q. That's how you would say that out loud. Just make sure you say it in the right order. Some people might not. Please do. But can you factor? Can you do something creative? Is there any way to like factor that, or is there some trig identity we can use? No. Sure doesn't look like it. It sure doesn't look like it. So you're kind of stuck at this point. What would you have to do at this point, given what you know about limits?
Put like 0.001.
Look really, really close to it, right? So let's do that right now. Let's go in. Let's go to y1. Let's clear these out. It's not that hard to type this in, right? Sine of x divided by x. Let's zoom trig. We're looking at it around 0, correct? Is that actually a pretty calm curve?
Yeah.
It's actually a very calm curve. So if we actually do this here, let's zoom in. Let's just zoom box. Why not? If we zoom box, I mean, it doesn't look like it's going berserk, does it? I don't think it's going berserk. If we look at this picture, what do we think the limit is as x goes to 0? What does it look like it's going to?
1.
It looks like it's going to 1. It looks like it's a 1. Now, do you pretty much believe that it's going to 1? Like, would you bet money on that? No? I guess I'm teaching you to be cautious here. That's actually really good. But it does look like that this value right here is 1. So you do kind of believe that the limit as x goes to 0 of sine x over x is 1. It actually is. Here's the thing. Are we going to prove that right now? No. We're not going to prove that right now, but that's something you can now believe. By looking at your graph, by looking at a picture, you're pretty sure that this is equal to 1. If you zoom in even further and it stays flat, does that make you believe in it more? Yeah, so your calculators can show you some truth. If you zoomed in and you saw this, is there a problem? Yeah, well, not a problem. It's just probably that limit either won't exist or is a lot harder to find than just looking at a picture. So just once again, remember your homework number 3 here, and D&E means does not exist. We're not done yet. You should know this at some point. If you're traveling along, if your function is traveling along and it spikes infinitely up, what do you call that dotted line? Let's say that's x equals a. What is that called? What kind? Vertical. Spell. Can anybody spell asymptote for me? Asymptote. Yeah. It's a vertical asymptote. So on this function, if this is f of x, can you tell me what's the limit? What happens to the function? What's the limit x goes to a from the left of f of x? As you get closer and closer to a from the left, what happens to this function? It gets infinitely high, right? So what happens, let's say it did this on the other side. You've seen asymptotes where it goes like that, right? You've seen that before? Yeah. What about this side? If this is still f of x right here, what's the limit as x goes to a from the right? Negative infinity. Here's a key thing. Infinity, is it a number? Yeah, is not a number. The other thing is it goes to infinity from the left and it goes to negative infinity from the right. So what would you say about what's the limit as x goes to a? When I say this, when I say limit as x goes to a, just a, that means both sides. So if it goes to two different things, what do you say that the limit is as you go to a? It goes to positive infinity from the right and it goes to negative infinity from the left. It does not exist. If the sided limits are different, if the limit as x goes to positive a of f of x does not equal the limit as x goes to a from the left of f of x, then what? The limit as x goes to a of f of x, what do we say? D and e. So sometimes, here's a simple version of this. Let's say a function went to here on the left, and it went to here from the right. Here's x equals a. It's going to different values. So what do you say the limit is as x goes to a? Does not exist. So what's one way to prove the limit doesn't exist? Show that the left hand does not equal the right hand. That's it. There's a lot of text to explain this in your book, but that's a simple way of putting it.